Hi everyone, my name is Alan alongside my partner Adam. We are Group 11 here to present the Site Assessment Credit. This is a new credit in the latest LEED V4 version. This is a 1-point credit which applies to all projects including new construction, core and shell, schools, retail, data centers, warehouses and distribution centers, hospitality, and healthcare buildings. The intent is to assess site conditions before design in order to evaluate sustainable options and inform related decisions about the site design. It evaluates environmental features that the design should take into consideration. It identifies assets, for example, favorable climate conditions, solar access for solar panels, plant populations, local animal habitat, and wind direction. It also identifies issues with the site, including unhealthy soils, steep slopes, and extreme climate patterns. It incorporates a site's ecological and historical context to the design. The site assessment also informs good design decisions. For example, placing plants in fertile soils on the site, placing outside gathering spaces near large trees or under the shade, and it orients buildings to take advantage of prevailing winds. The site assessment is conducted before or during the conceptual design in order to honor a site's unique characteristics. Understanding a site's topography, climate, soil type, and water availability is important because these features can influence a project's design and ultimately its performance. So the requirements, as far as the documentation that's required, you need a site survey or assessment, plan or map, as well as the site assessment worksheet or equivalent narrative, and you can find that in USGBC's website.
Okay, next. A site survey or assessments must be completed and documented that include the following information. There are 7 of them, which are topography, hydrology, climate, vegetation, soils, human use, and human health effects. Alright, let's go ahead and start with topography. To do that, we include sufficiently detailed site contours to show the general topography of the site and its original surroundings. Also, showed unique or significant topographic features such as rock outcroppings, irregular topography, and the direction of overland water flows. Also, to identify steep slopes or areas that are at risk of slope failure is important. The next one is hydrology. To do this, we need to show existing surface water resources such as lakes, streams, estuaries, and delineated wetlands and associated buffers. And to identify flood hazardous areas, coastal hazardous zones, or other flood prone areas of the site. The next one is climate. We need to identify the solar exposure using seasonal sun angles, solar access and shading, solar intensity, and amount of direct sun versus ambient light on cloudy days. Also, to determine the seasonal prevailing winds, including range of wind speeds and average wind speeds and direction. To collect the annual and monthly participation patterns and determine whether the rain tends to fall in a few large events or in more frequent but smaller events. Also, survey pavements and roof surface to identify the potential heat island effects of any existing structures. Next one will be vegetation. To do this, we need to inventory the location and type of significant trees, invasive plants, and any threatened or endangered species. Also, to indicate the location and limits of greenfield areas and habitat corridors that may support local wildlife. For soils, we need to determine whether the site is designated as prime farmland and to identify the soil classification by the Natural Resources Compensation Service, and to identify the location of healthy soil as well as previously disturbed soils, to develop a soil management plan to improve poor soils and support vegetation. For human use, we need to document the previous, current, and future known uses surrounding the site to establish a context for human use, and to include the location and condition of on-site buildings and infrastructures, to identify view corridors that can enhance occupants' experience in outdoor gathering spaces and buildings. Also, to include planned infrastructure adjacent to the site, such as future roadways, bicycle networks, mass transit, and major pedestrian facilities. The last one will be human health effects. To do this, we need to identify opportunities for physical activity on or adjacent to the site, such as trails, playgrounds, athletic fields, and gyms. To locate major sources of air, water, and noise pollution that may affect future planning. And to identify nearby hospital, child care centers, schools, and senior centers whose occupants may be vulnerable to on-site pollution.
So finally, there are 4 steps to improving the site assessment. It starts with the first step, that's preparing the assessment. Ultimately, you want to identify the team that will be doing the assessment. Secondly is conducting the site inventory. You'll use a variety of data sources, site visits, and local experts. You will survey and inventory the existing site conditions and surroundings according to the credit requirements and compile the information for the site assessment. Thirdly, you'll conduct the site analysis, that is preparing a site plan that includes the required information gathered during the site inventory, and analyze the effect of the site features on the project design. Finally, you'll complete the site assessment worksheet and prepare the site assessment. This involves completing the USGBC site assessment worksheet that's provided on their website, or you'll develop a different narrative so long as the site inventory is included and the site analysis is completed. That's all for this credit. If you have any questions, ask your TAs. Thanks for your time.